So in this video we will start with a new series, that is the microprocessor design series. Okay, so what is a microprocessor? So microprocessor is a computing device which can perform arithmetic and logical operations. So it is a very important subject for any kind of computer engineer or electronic students, because a microprocessor is currently used, or a microcontroller is currently being used to build a variety of embedded systems, robotics and all those things. So you should have profound knowledge of this subject to scale up with the ever increasing need in this field. Okay. So why you should learn about microprocessor? So as I said earlier, uh, in the current systems, now the whole world is moving towards embedded systems. Previously, all the electronic systems were built over something called as a control systems, which were designed, you can say, using mathematical laws like proportionality, integral, and derivative. So that kind of systems were really hard to maintain. So now that systems are being replaced by much easier to maintain and design embedded systems. So at the heart of these embedded systems, there is microprocessor or a microcontroller involved. So it really makes sense that you start learning microprocessors and their architecture, so that you could actually contribute towards these fields. Okay. So apart from that, learning about microprocessors or the internal hardware architecture of a computer, you can say a microprocessor is a small computer, right? So that helps your understanding of the computer as well. Okay. So I suggest you should learn it, even if you are not pursuing any career in embedded systems or as such, because learning about microprocessor helps when you are going to optimize your systems. If you know the architecture on which you are going to perform a program or run your program, then you can optimize it on that hardware as well. Okay, so this is also important when it comes to designing games and all those things. Okay, so this is also a very important factor. So here you would see a generalized architecture of a microprocessor. Okay, so in general, I have shown a microprocessor, what it looks like. In the upcoming videos, we will get into much better details. But for now, this is what a modern microprocessor has. Yeah, the size of these registers and all those things can vary, but this is what a generalized microprocessor should have. An accumulator, ALU, that is the arithmetic and logical unit, the working registers, or in other words you can call general purpose registers. This kind of registers are kind of scratch pad, you can say. Means you write some values into it, you perform some operations in the ALU, and you display the results, and you store the results in the accumulator kind of. Okay. So then there is the interrupt circuit. Okay. So interrupts are also an important part of a microprocessor. Then there is something called a stack pointer and program counter. So the stack pointer, as you all know, stack memory is used to store the data whenever an interrupt is occurring or something like that. So these two are also, means they are pointer registers only. So that are also important part of the architecture. And then finally we have a timing and clock circuitry. So this is what defines or determines the speed of your microprocessor. How fast is the clock? Faster the clock, or you can say the oscillator, the faster your microprocessor will be. Okay. And also the size of the registers, the general purpose registers, that determine the size of the microprocessor. Okay. So when you say 8-bit microprocessor, it means that general purpose registers of that microprocessor are 8-bit. When you say a 16-bit microprocessor, the general purpose registers of that microprocessor are 16-bit. So likewise. Okay. So we shall continue in the upcoming videos with this. This was general introduction. In the further videos, we will try to design a small microprocessor of our own, which will have its own set of mnemonics and opcodes. What is mnemonic? What is opcodes? We will discuss in further videos.